What's going on, math people? We are back, and this time we're talking about derivatives of trig functions. All right, there are 6 trig functions, so that lets us know that we have 6 derivatives that we have to take in mind. All right, your root functions are sine and cosine. Their derivatives are the first ones that appear on your left hand side in that first column. All right, now tan, secant, cosecant, cotangent, they're all functions that are consisted of the root functions, and their derivatives can be calculated if need be. And the way you would calculate them is to use the quotient rule. Now, I don't have any kind of fancy way to help you memorize these trig derivatives, but you need to program them in your head, because some profs gonna be like, you ain't getting no formula sheet. So go ahead and get those programmed. And if you aren't able to get them programmed, hey, you're geniuses, okay? You can calculate it, and I'll show you an example of how to calculate one later on in the video. All right, so let's jump into utilizing trig derivatives. With trig derivatives, I will also add that you'll be applying the chain rule throughout these trig derivatives. All right, so let's jump into an example. All right, so trig derivatives is what we're working on. Trig derivatives. All right. Now, it has sine of x on the screen, and it was focusing specifically on that x variable. But that function can be something different. So, let's say that the function was, let's say we have y equals sine of u. And let's say u is a function of the variable x. All right, so if we wanted to find the derivative of this, or we'll say the derivative of sine is cosine of u, and then you have to take the times the derivative of u with respect to x. That portion right there is the portion of the chain rule that you apply on every single trig derivative. So let's jump into some examples. You know we don't like to waste the time. All right, so if you're having problems with chain rule, I posted a nice little video giving you loads of examples of the chain rule. Check it out. All right, so we have an example. We say y equals negative 4x plus 9 cosine x. This is our first example. And it wants us to find dy dx. All right, so we want to find the derivative. If we go back to that handy dandy trig sheet, we know that the derivative of cosine is negative sine. So we're just going to go ahead through this problem. With the first piece, we have negative 4. That's nothing new. We've been applying the power rule for some time now. Plus 9 times the derivative of cosine. Just going to add in some color. The derivative of cosine is negative sine x times the derivative of x, which is 1. Because remember, I told you, you're going to be applying that chain rule all throughout. I really hate how they focus straight on, first off, on a specific variable whenever they post these sheets. I personally believe you should post these that show this. You're going to have to take the derivative of that piece inside of that function. All right, final answer equals negative 4 minus 9 sine x. All right, that one's pretty cake. The ones that are not so cake is when you're getting in there and you've forgotten some of those trig derivatives, and you're like, oh man, what is happening? All right, so let's say we have an example like something like, oh, here's one to try to slide in some action and see if you was paying attention to all your information from the past. It hit you with one something like this: y equals x to the 6 times the sine of x. If you look at that real quick, what's happening right there? All my math people said the product rule is happening, baby. So, hey, don't forget the product rule. Don't forget the quotient rule. Go ahead, pulling out the product rule right here. You have your two terms. U is x to the 6. V is sine x. So, u prime, 6x to the 5th. V prime, derivative of sine is cosine of x. And your boy got some of them trig things programmed in his head. All right. Dy dx, or y prime, is product rule. The first times derivative of the second plus the second times derivative of the first. Write it out a little bit more clean. You have x to the 6 cosine x plus 6x to the 5th sine x. They'll try to get you to slide back in some of your information that you should have already retained. They'll see if you retained it. They'll try to slide it in. So don't forget about your product rule. Now here's a problem that gets real funky, okay? This problem is just stank. But hey, y'all got this. We in this together. It wants us to find the derivative. We have y equals cosecant x minus 8 square root of x plus 2 over e to the x. Don't panic. Don't panic. The first thing we're going to do is clean up the house, because when your house is clean, you can see things better. So we're going to get rid of some of those symbols and get some of that stuff out of the denominator. We're not taking derivative yet. We're just rewriting. We have cosecant of x minus 8 times x to the 1/2 power plus 2 times e to the negative x. All we did was rewrite. That's all we did. All we did was rewrite the problem right there. Now we're about to start jumping into this derivative talk, right? Now let's go back. Recall that the derivative of cosecant of x is equal to negative cosecant x cotangent x. All right, so we're going through now, finding the derivative of our problem. We're gonna write the solution in black so we don't mix things up. Dy dx is equal to derivative of cosecant negative cosecant x cotangent x times derivative of that x inside of that trig function, which is 1, minus 8 times derivative of that variable there, which is 1/2 x to the negative 1/2, because we subtracted 1 from that. I'll write it just so you can see it. We applied the power rule there. We had 1/2 minus 1 plus 2 times e to the negative x. We took derivative of e times derivative of that x and the exponent there. That gives us negative 1. All right. Simplifying, cleaning it up, we have negative cosecant x cotan x minus 4 x to the negative 1/2 minus 2 e to the negative x. All right, let's put our information back with the symbols and in the proper location with respect to the exponent. So we have negative cosecant x cotan x minus 4 over x to the 1/2. That 1/2 moved to the denominator because it was a negative exponent. That negative exponent says I'm in the wrong place, put me in the right place. Then we have minus 2 over e to the x. Same thing, negative exponent. Finally, we're going to go back and add in our symbols for radical expressions. And we have 4 over the square root of x minus 2 over e to the x. That's that guy right there. All right, that's the last example for as far as the trig derivatives go. But I told you, if you got in a crunch, you can calculate any of the remaining 4 functions. So let's say, and I say you can do this using the quotient rule. Let's say you have y equal tan x, and it wanted you to find the derivative. Find dy dx. And you did not have that programmed in your memory bank. Rewrite it as the root function. The root function, we know that tan is equal to sine x over cosine x. Once you rewrite it, apply the quotient rule. And when you apply the quotient rule, you'll get your answer of what that derivative is. It's the long way around, but it's better than saying, I don't remember. So we have quotient rule. Quotient rule, we have the bottom times the derivative of the top. Derivative of sine is cosine minus the top times the derivative of the bottom. That gives me derivative of cosine is minus sine all over the bottom squared. And what we have here in the numerator, we have cosine squared x plus sine squared x over cosine squared x. When you apply your trig property, sine squared plus cosine squared is equal to 1. So you have 1 over cosine squared x. And we know that 1 over cosine, we can rewrite this as this. 1 over cosine is equal to secant So we have tangent x, well, the derivative of tangent is secant